infinity over infinity, here's the saving grace from L'Hopital's rule. And the limit as x approaches c of f prime of x over g prime of x, if it does equal a nice number, not this stupidity up here, not this stupid 0 over 0 crap, then we know that the limit as x approaches c of the original thing is equal to whatever we found right here when we did the derivative of the top over the derivative of the bottom. So I'll give you a second to write that down. That is L'Hopital's rule, and boy does it come in handy. It did not used to be in the content standards for AP Calculus, but they added it in a couple years ago, and it sure does come in handy in certain situations. So let's look at a couple examples here of how we tackle this. Here is example number 1.
Can you put that back up, please?
Yes, I sure can.
Thank you. Sorry.
I'll give you a minute to get that all down. And what's funny is there are even different spellings of L'Hopital. Sometimes some people will put, some textbooks will put an S here, so it actually looks like L'Hospitals, H-O-S. They'll sometimes put an S in here. Don't ask me why there's 2 spellings. I'm not in charge of that department. But typically it is just pronounced L'Hopital's rule. All right, are we good to move to the next screen?
Yes, thank you.
Okay. So here we have an example. The limit as x approaches 0 of 1 minus the cosine of 2x over 5x. All right. Well, if we want to try to find the limit of this, I told you that we always try substitution first. That's going back to our days when we learned about limits. All right. So we're going to try to substitute first. And if I substitute, I would have 1 minus the cosine of 2 times 0 all over 5 times 0. And in case you forgot, the cosine of 0 is 1. And the quick way to remember that is to draw yourself a quick little mini sketch of cosine. Here's 0, and here's 1. The cosine of 0 is 1. So I have 1 minus 1 over 0, which, let me show you a problem with what I just wrote here. The College Board does not like for you to put that it equals 0 over 0. They want you to use arrows. All right. So, and the reason is because technically this indeterminate form is not a value that we can consider. Serving as a reader for the AP exam, there was actually a question a couple years ago where students lost the point if they put an equal sign right here. So you do not, with L'Hopital's rule situations, you do not want to put an equal 0 over 0. You want to put arrows, and you want to say this is an indeterminate form. And what is nice is to say something like L'Hopital's rule applies, something like that. All right. So L'Hopital's rule says that I can now do f prime of x over g prime of x. I can do the derivative of the top over the derivative of the bottom and then evaluate the limit. So the derivative of the bottom is easy. That's 5. The derivative of the top, well, the derivative of cosine is negative sine. And so since I have this negative here, it's going to become the positive sine of 2x. And I have to use the chain rule, so it'll be times 2. All right. So there is my f prime of x over g prime of x. And now I can evaluate the limit as x approaches 0 of that new expression, 2 sine of 2x all over 5. And we're going to try to do substitution. So this is equal to 2 sine of 2 times 0 all over 5. And the sine of 0, the 2 times 0 is 0. The sine of 0 is 0. So this limit is equal to 0 over 5, which is okay. The limit is 0. And so we can use the equal sign here. All right. My final statement, though, is this 0 is the limit of what we were looking for at the beginning. So my final statement is that the limit as x approaches 0 of 1 minus the cosine of 2x all over 5x equals 0. All right. So L'Hopital's rule really just boils down to, can you find some simple derivatives? Okay. Let's look at another. Is everybody okay on this screen? Before I go to the next. All right, let's go to the next problem. Okay, this is the limit as x approaches 1 of the natural log of x over x squared minus 1. So the first thing we want to find out is, does L'Hopital's rule apply? So we're going to try to substitute. So once again, I'm going to use arrows here since this thing is a fraction. You never know when it could be L'Hopital's rule. This is the natural log of 1 over 1 squared minus 1. The natural log of 1, in case you forgot your graph of natural log, there's your graph of natural log. The natural log of 1 is most definitely 0. And look what I did by accident. I put that equal sign. I'm going to change it to an arrow. 0 over 0 is an indeterminate form. So L'Hopital's rule applies. Okay. So L'Hopital's rule applies, and let's find the derivative f prime of x over g prime of x. What is that? Well, the derivative of the natural log of x is 1 over x. And the derivative of x squared minus 1 is just 2x. And so now we try to evaluate the limit as x approaches 1 of this expression, 1 over x over 2x, and we do that by trying to substitute first. 1 over 1 over 2 times 1 is 1/2. So the limit as x approaches 1 of the natural log of x over x squared minus 1 is 1/2, thanks to L'Hopital's rule. All right, I'm going to move on. If you need to catch up on any of these slides, I'll post the video later after YouTube gets done processing it. Let's take a look at this one. The table above gives selected values of a twice differentiable function f of x. Find the limit as x approaches 3 of f of 2x minus 1 all over x squared minus 9. Let's try substitution again. So I'm going to find f of 2 times 3 minus 1 all over 3 squared minus 9. So the bottom is definitely 0. The top, let's see, 2 times 3 is 6 minus 1 is 5. I need to find f of 5. So I come up to my table. F of 5 is 0. Uh-oh. Indeterminate form. So we can use L'Hopital's rule. I'm trying to learn how to get my big farm hands out of the way here. L'Hopital's rule applies. So the derivative of the top. The derivative of the top. Well, that looks like a composition of functions to me. Okay. That is most definitely a composition of functions, so I need to use the chain rule. So on top, I have f prime of 2x minus 1, f prime of 2x minus 1, times the derivative of the inside, which is 2. Okay, so what I'm finding here is f prime of x over g prime of x. The derivative of the bottom is just 2x. So it looks like my 2's cancel. And I now need to evaluate the limit as x approaches 3 of f prime of 2x minus 1 over x. So let's plug in our 3. So that is f prime of, if I put my 3 in here, 2 times 3 is 6 minus 1 is 5, f prime of 5 over 3, and f prime of 5 is information from the table. Yay for us. F prime of 5 is 7 over 3. So the limit then as x approaches 3 of f of 2x minus 1 all over x squared minus 9 is 7/3. And that is the conclusion of our notes on L'Hopital's rule.